down to the bottom here. Just continue on. I hate that landing page. Okay, I'm going to invite you.
Okay.
3, 2, what?
There's so many people with that name. It's like
no, your staff.
so cool.
What's your plus? It's re2 at TAC.
Attack.utexes. No. RAUTA. I'm sorry. RAUTA.
Like that?
Yeah. Attack.utexes.edu.
There you are.
Okay.
Okay, you're gonna get a phone call over here.
That's what it is.
There's no, not start. Review all.
Okay.
No. Okay, that's why I'm here to help.
Could you send me
Can you send the invite one more time?
Yeah.
What is it again? RAUTA
at attack.utexes.
RAUTA?
Yes, that is correct.
There you are. Invite. Back to your plus. Back to this plus page. Can you see this real quick? Why aren't you getting the invite? Okay. Do you have your email up on here?
Oh, no. Yes, it was everything.
RAUTA, correct?
Yes.
Okay, I'm going to send you an email invite.
Okay.
So go ahead and open your email. Oh, hold on. Go back now. I see. It looks like you weren't actually, it was taking a minute to log in or something. 3, 2. Okay. Well, it's not going anywhere. Let's just go ahead and go to your email. And you should have just received an email from me.
Does it go to junk?
Maybe junk?
No. No.
There it is. There you go. And then join. Are you using Internet Explorer?
Yes.
Are you serious?
Yeah. Do you think it's an ID issue? Could be.
Yeah, I have read. Okay. Join. And now, importantly, we need to mute.
Okay.
And what I'm going to do is I'm going to mute you over here. Mute. And so this microphone will pick you up.
Okay.
Basically what we'll do is right now we're seeing your face. So what we want to do is we want to do share.
This one?
Yep, screen share. Full screen. Yep, start screen share.
So my screen will be shared. Okay.
Correct. And now you can open up your presentation.
Nice.
Go to your first slide there. Oh, and we need to have it over there, right? So we need to go to projector only. There we go.
I wish it comes up. It's not coming.
Got it behind you.
Oh.
Why isn't it
This
coming
is
through here?
funny.
I know, never done. Oh. Okay, now I have it over here. Nothing behind us.
Oh, man.
Well, what I can also do is I can just set you up on this machine. Would you like to do that? Okay.
Oh, now that would be a challenge for me because I'm really challenged for navigating Mac.
Mm-hmm.
So if it's like that, and there's no way. Give me just 1 second.
Sure.
If I do this, just
Right behind you, there's no delay. What do you want to get to?
this guy.
Okay. Oh, this is the whole video? You're on it. There you go. But you need to have it.
Okay. So.
Do you want to send me your slides and I can open them up here?
That's a very good idea.
Okay.
That's a very good idea. Okay, let's do that. I can't get my mouse back. Maybe.
You turned it off.
Yeah, and then they charge you. Well, for ours, they just charge you $200, and you get the stuff you have to figure it out. I didn't want to pay it. I know that's the contract fee. I'm really just tempted to like, because I'm pretty sure she might not want to pay for it, but I'm really just tempted to pay. But it looks like you want on it. Yeah. But I think I would tell July. I never want to. Yeah, you gotta protect yourself. One game we were laughing at was the shuffle, because it was like she was complaining that we have a cricket problem. It's like, I don't know what it was. Let's go straight.
For the slides.
Yeah.
Are these remote people Exceed scholars?
We have a handful of different people.
Oh.
We do have some Exceed scholars out there. Okay, download. And so you have lecture 1 and lecture 2. Okay, don't want to do this.
Yes, go to the next slide.
So here in the downloads folder, you see these 2 lectures.
Yeah.
I'm just going to open them both for you. Command tab is just like Alt tab. Yes, I see you bouncing over here. Okay, so there's that one. This is lecture 1. Let me open lecture 2 as well. So you have them both right there. Groovy. And view. Oh, and then what I'm going to do is from the Hangout, I'm going to go ahead and drop you. Actually, you'll have to do it. Go to your Internet Explorer there, and you can go ahead and hang up. Mm-hmm. There we go. All right, so it's just here. What I'm going to do is I'm going to do the screen share. Share the entire desktop. Infinite windows. And you'll see here the lecture 1 is right here, and it's just view. How do you do this? You view full screen mode.
If you try to follow, look.
And then let me fix this. Routing, PC, send everything. There we go. Now you don't need this guy at all. You can do it all from right here. You can use this guy to advance, or you can use the arrow keys. Is that okay?
Not quite, because if I have to go to SSH terminal,
Escape. Bring you out of there.
maybe let's get started. It's 108.
That's okay.
Whatever,
You got time.
Yeah,
If you want
so
to bring up a terminal, you just hit escape to get out of the full screen mode.
maybe I'll just do board work. That's okay?
Here you go. Check it out. Let me show you something. Command spacebar brings up this little search bar, or you can just click on it. Little search. Type terminal. And I don't know why it's bouncing down here. There you go. You have a terminal. You can change colors if you want. If you want it white, white's usually fine. Command plus makes it big. So what I usually do is just close this one. I don't know why iTunes is open. There's a terminal. Remember Command Tab to go in between them. You have two of them up there. You can select whichever one you want. And again, it's just view full screen mode.
I hope I remember that. Else I'll just do the board work in that situation. So that yeah, slightly too much to remember, but maybe I'll
You can close this guy. You don't need that. It's not driving anything.
No, this is just for my reference.
Okay.
Okay, so maybe I'll get started.
All right. And you remember how to get back to the terminal here?
I'll just progress here.
If you want to get back to the terminal, just hit escape. Or you can alt tab as well. Yeah, you can just do that.
Yeah, I'll just do that.
Groovy?
Thank you.
Okay. Yell at me if you need any help.
Okay.
I think it's going to be there. Okay, the next time I'll be more assertive. Yes, just say the name.
Are we being assertive?
Well, the problem was that last job where I accidentally did it on the phone.
That's the bottom one.
Yes.
Hi all. My name is Ritu Arora and I work here at the Texas Advanced Computing Center. And I'll be giving you a short overview of programming in C. So I believe you guys are already up to speed with Linux. And if not, we'll do some of it in the lecture as well while we run some small programs. So how many of you can get to Stampede? Are you all working on Stampede?
Yes.
You all can log in?
Yes.
Okay, awesome. And then, do you know how to create a file?
Yes.
Yes.
VI, file name.
This is yes.
Yeah, this guy.
Yes.
That's the command line. VI in small,
I don't do business.
name of the file, and say.
You're using Nano.
Oh, you use Nano? Okay.
Nano.
You can
Nano.
say Nano.
Nano Squad.
Test.c, something of that sort. Okay? Okay.
Would you like us to do that?
Yeah, it's nice to be prepared.
Okay.
Open a file. So because we have very less time, and I believe at least one person here already has attended this class with me. How many of you are already familiar with C though? Woo! You guys don't need a teacher here. No.
Wait, C, that's the same as C++.
Well, a close cousin. I mean, if you know C++, C, in not truly mathematical sense, but in some sense, can be considered as a subset of C++. So whatever you can do in C is valid in C++. But not everything that you do in C++ is valid in C. Okay? Okay.
What would you say would be the main difference?
In C and C++?
Yeah.
So in C++, you do object-oriented programming, right? You create classes, objects. We don't have that notion here in C. C is a procedural programming language. And it's like a sequence of statements that you're following in order to get your work done. But in C++, you have a notion of objects and classes. You try to model your program in terms of abstract concepts, and you try to make objects of those in the form of like, you can make concrete classes, you can make concrete objects, you can make abstract classes. So it's like a blueprint that you give in the form of a class of what you want your object to be. Then you create objects of those things. And it's a very poor explanation because I'm trying to keep it short, but at the same time, I'm not doing justice to explaining what C++ exactly is, because it's one language in which you can do type-independent programming. When I say type-independent programming, you can use template, like function templates and class templates, to write your code such that at runtime, depending upon the argument you pass, you can have the code specialized. That's one difference. You don't have that facility in C. C. And there are a few more things like those, like notion of object-oriented programming, then the notion of templates. We don't have templates in C, unfortunately. Are you familiar with templates? No? What do you do in C++?
I don't really remember. It's been like 3 years.
So you basically use C out, C in for printing and reading stuff. That's, okay. So, okay. In C, you will have printf and scanf, which are analogous to C out and C in. And printf and scanf work in C++ too. That's why, like, saying that everything that works in C most often, or maybe all of it works in C++ as well. But you don't, as I said, you don't have a notion of classes and objects and templates here in C. Okay. Somebody dropped a coin here. Somebody has maybe lost properties. Somebody can find it later. Okay. So now that our friend there in yellow T-shirt has reminded us about C++, let me give you a quick overview to the history of C. Well, first there was B, then there was C, and then there was C++. Now, B was the programming language that was developed at the Bell Lab, and they also had another programming language that they were working with called BPCL. They merged the two together, like B and BPCL, to come up with C, and then one level up was C++, not B. So from B, they went to C, then from C to C++, basically. So that tells you that everything that's there in C or will be there in C++. But not everything that's there in C++, you'll find it in C. Okay? So, the reason why I wanted you guys to open a file is so that you can type out whatever we are doing and see how things work as we progress. So, the first thing I would want you all to do is have a Hello World program in C. Okay? I know it sounds crazy. I haven't told you what a program looks like, but I want you to write a program, doesn't it? But don't worry. I'll walk you through the process. In general, yeah?
What do you run this program
On Stampede. So currently, whenever I give you instructions, try to type that out here. Save a file. I'll give you all the steps. So, in order to write a basic C program, or maybe any program for that matter, you would need to have an idea about what to program, right? That's the starting point. Then what you would need is write the source code in an editor, like you have Nano, or VI, or TextPad for that matter, any editor. Then you have to save the program, and here You have to remember that when you're saving a C program, you have to save it as a .c file. Just like you save a text file with .txt extension, when you save C programs, you save it with .c extension. And then you have to compile the program. We will come to compile, what compiling means later. But for now, just bear with me when I tell you that the next step would be you have to compile the program. And if there are any errors in the program, you go back, fix those, then recompile the program, test it. If there are errors, go back, fix those. So this cycle continues till the compiler is happy and you get what you want to see on the screen. That is when you run the program. And yeah.
Oh, I just have a quick question. If we're using Nano as our
Editor.
Do we have to run the little SQ thing that way, or can we just run it through there?
Well, I hope nobody else is listening here from my colleagues, because it's okay to run this tiny mini program on the login node. You don't need to do SQ for that one. But if a program takes more than 30 seconds or maybe a minute to run, well, let me take that back. If it takes more than 2-3 minutes to run, it's better to submit it via queue using SQ. But for what we're doing, it's a really tiny thing. It's going to run in a fraction of a second, really a fraction. So you don't need to go to the queue. And we will show you how to do that. Okay? So this is how, oh, I promised you. This is how a C program looks like. All I can tell you is by the end of the lecture, you'll be able to tell plain text from C program. I do not guarantee you that I'll make you an expert C programmer by the end of the session, but at least we'll have you up to the speed so that you can recognize, oh, that's a C program, that's what it looks like, okay? And then I'll show you what all you might want to be looking up for learning this thing beyond today's session. So, if you look at this guy, like the first thing in there, oh, there's a pound sign, and it says hash include stdio.h, int main, printf, introduction to C, return 0, and bracket close. Now, if you pay close attention to this piece of code, you would notice that there are a bunch of funny brackets, all sorts of angular brackets, curly brackets, round brackets. Then there is some punctuation in there. There is a semicolon somewhere. Yeah, there are 2 semicolons in there. Then you would notice we have double quotes in the program. Then there are words that you recognize already, like include, it's an English word, right? Main, that's an English word. Return is an English word. So a bunch of words that you see on the screen that are straight out of English, right? C is a mid-level programming language. So there are 3 levels of language, if you will, that you can imagine. There's a high-level language, there's a mid-level language, and there's a low-level language. Low-level language is the language that gives you a program that runs in a language which is very close to what the microprocessor understands, the machine language. Then the high-level language, it gives you the flexibility to do what you want to do at a really high level or an abstract level. And C is somewhere in between, like Visual Basic is an example of a very high-level language. Now, C sits somewhere in between. It gives you syntax and semantics to write your program in a high-level manner, but the speed and efficiency it gives you, it's so close to what you would get when you're writing the program in machine language. Of course, machine language program is going to be the fastest one, but C is slightly slower or somewhat close to the machine language. So you can make everything in your computer move by writing one C program, right? That's what your kernels do, right? Are you guys familiar with different types of programming? There's system-level programming, application-level programming, right? What we are doing in today's session is application-level programming, but C can be used to do system-level programming as well. Okay, I call it application-level programming not because I'll have you write applications, but I'll just show you how to write small, teeny-weeny programs. Those are tiny applications that we'll be looking at. So my intention, if you go back to the slide, the first one, the first thing says you ought to have an idea about what to program, right? So my goal here with this program is to print the message Introduction to C on the screen. That's what my goal is. Okay. In order to achieve this goal, I told you I have to write a program in an editor. That's what all of you must already be having. Nano program name. Okay. Now, what do we do to tell the compiler to print Introduction to C? Okay. It's not simple as just writing a string. Because, why? Why can't I just put like Introduction to C on the screen in double quotes and have it printed on the screen? Maybe in Nano, if you type Introduction to C, and do you think that would just work? No. Because C has some syntax, you've got to have the guy understand what you want to do. And that's why all this syntax that you see on the screen is just required. It's just required to get the string Introduction to C printed on the screen. So in C, as I told you, it's a procedural language. It's basically you write your program in terms of functions or procedures. And one key ingredient there is main function. So all C programs ought to have one main function. That's the starting point of your program. Okay? So when you give your instruction that you want to implement inside your main program, in your main function, this program is compiled by a compiler, and the executable is created that is heard to the operating system. Then the operating system tries to interpret what you want to do. Then it calls its routines internally to print the message Introduction to C on the screen, right? So main is the engine of the program. So you ought to have main, a main function. So let me underline this guy if I can get this mouse to move. Okay, here. So this is the starting point of the function of the program execution, main function. And main, in the name of the function, and the name of the function is main here, and its type is integer. Okay, before I get to the types, so when you started learning English or math, you started with basics, right? Numbers, 1, 2, 3, 4, alphabets, A, B, C, D, right? Those are different types. So, and then when you started doing your math, you learned that there are integer values, there are whole numbers, there are decimal values, right? You can have rational numbers, you can have irrational numbers. So in C, we don't have a notion of like irrational numbers or rational numbers, but we do have a segregation. We have integers. So in order to handle integers, we have a data type called int. In order to handle characters or strings, we have a data type called character. In order to handle decimal values, or when I say decimal values, I really mean fractional values. You have something called as double or float. Okay, we will get to all those data types later. But because this guy int popped up first, I thought I'll just give you a quick introduction to the data types here. So what this line, I'm starting with the second line at the moment. So what this line means is my main function has a return type of int, integer return type. Okay, I'll explain all those things later. But for now, I'm just trying to explain you the thing at a high level. So that's what int means, like integer. And main, as I said, is the name of the function. Then you have round brackets. That's a syntax that you have to remember. In C, when you are writing functions, the function name is followed by round brackets. Okay. Now the round brackets might have some stuff inside that, which is called as arguments, or it might be just plain like this, no arguments in it. Okay. And then we have curly braces beginning, and all the steps that you want your program to execute, that's put inside the curly brackets, like this guy and this guy. So there's an opening curly bracket and there's a closing curly bracket. And as I told you, my only intention about this program was to print a message, Introduction to C on the screen. In order to print this, I need a function. C language has a library of functions that you will get when you install the compiler. Okay, so there's a library, or somebody else has already written the implementation of the function called printf, which means formatted printing. So this function is already there in the library. When you call it, you'll be able to print what you want to print on the screen. So this guy, printf, you just use, it's a function. And how do you know that? Because you have round brackets here, right? Where do you see another set of round brackets? Main, right? So printf, just like main, is a function call. But the difference is, main is the engine of your program. You ought to have one main, and exactly one main in your program. Okay? There can be no one else but main driving your program. And you can have a bunch of other function calls from within main and from within other functions. Okay. So now this guy, printf, that's implemented in a library file called stdio.h. Okay. And that is why we have to include that file. Okay. Now let's look at this program in more depth. We have hash include as the first element, hash or pound, right, as the first element in the program. In C, that's called a preprocessor directive. By a preprocessor, what I mean is there's a component. So there's a component sitting there with your compiler or a piece of software that will look at your code, and wherever it finds something like hash include, it will go and read its following part. It says hash include stdio.h. So the preprocessor, it will comprehend that you're trying to include the contents of the file named stdio.h in your program. Exactly, that's what it does. Okay? And where is this file again? It's in the set of libraries that you get when you install your compiler. You don't have to write any of that. It's there for you, already available. Because it's already available for you, it's called a standard library. Okay? So hash include, as I said, is a preprocessor directive that tells the preprocessor or another piece of software to pull this file stdio.h and plug its content into your program. And the reason why I need that is because I want to print something to the screen. And the guy that's going to do the printing is available inside stdio.h. Okay. Before I move any further, I'll request each of you to tell me at least one thing that you have learned so far. Perfect.
I was just about to say that.
Okay, let's say that same thing.
Main is recurring.
Okay.
Let B, C, C++.
Perfect, okay.
Inside the brackets of main, you can have an argument beforehand.
Yes, very good.
Function is accompanied by a couple of brackets.
Yes. And what kind of brackets?
But yeah, specifically, I don't like the ones like right after it. Like, what do you get the jar? It's like it's always
Round bracket.
The entire function is sorted by the.
Perfect. Thank you. Perfect. Perfect, great. You all guys strong, and you have 3 friends in the back there.
Already got what everything that's done in
Okay.
That you included the studio header.
Yeah, you're right. Yeah.
So that way this print is inside that like.
Awesome, thank you.
And other than just the VI test.c, just creating the file was the expense.
Okay.
Starting there was good.
Okay.
Is the return 0 there because of the nifty?
Yes, yes, and I'll explain to you every bit of that. Yes. Yes. Now, very good. You all are a great class. Now let's move forward, dissecting each component of this tiny program.
I just like to do it because whoever creates.
No, yeah, you're right. So whoever created C wanted it that way. You cannot have anything but integers returned. Yes, you're right. Okay, so let's look at the components in there. So hash include means, again, it's a token that tells the processor, the preprocessor, to grab the file stdout.h and push its contents into your program. Okay, and the file it's trying to grab is stdout.h. Note that there are angular brackets hugging stdout.h on each side. That's a syntax for it, right? Use angular brackets to provide the name of the header files you want to include. Then coming to the next line, you have int main. Okay, here integer is the return type of the function. The name of the function is main, and as our friends told here, we ought to have at least one main function in the program. That's the engine of your program. And then we have round brackets. They're empty at the moment. That means the main function is not taking any arguments. If you do not understand what arguments are, do not worry. We'll come to that later. So whenever you're trying to pass a value or pass something to your function, basically you're saying you're passing an argument to the function. That's when you would need an argument to accept that what is being passed to the function. Okay. So here main is not accepting any arguments, and hence the round brackets are empty. There's nothing inside them. Then begins your curly braces. So the contents of the function are placed inside the curly braces. Then you have the printf statement. And the printf statement again, printf is a function call. That's why it has round brackets. And here, if you contrast printf with main, what's the first difference you see? There's a semicolon, sure, but very good, yeah. But if you look inside the round brackets, printf takes an argument. It takes something that it wants to print. But main here did not take any argument, right? Okay. If you stare at this guy enough, you will notice that before the closing quote, there is something like /n, right? That's called a new line character in C. What it does is, it prints your output to the screen and progresses the prompt to the next line. Okay, that's what the /n guy is doing there. And then you see a semicolon. So everything that you write in C, like every statement, not the function body. I don't have a semicolon here. Except the function body, you will, and of course, except the preprocessor directive hash include, you will see that you need semicolon at the end of each statement in the function, right? In the main function, there are two statements, and at the end of the two statements, you have semicolon. Yeah, see, it's weird. It needs all those punctuations to function properly. Okay, then we have this guy, return 0. Return is a keyword in C, and by keyword, I mean it's a reserved word. It has a special meaning. The compiler has annotated a function with it. And what that does is, it marks the end of the program, and it returns 0 or any integer value to the operating system. Okay, why operating system, you might wonder. I just want to print introduction to C on the screen. But that's what you want to do. But there are some housekeeping activities involved when you run a program. And you might want to tell the operating system by sending a message that everything went okay, there was a graceful exit, and so forth. So usually, you would see like 0, it's the most common integer value that's used, but you could use -1 if you're trying to do some post-processing after your program is over. You could have different types of return values and then have different kinds of things executed on the basis of the return values. So here, it's return 0. You could have -1, you could have -2, any integer you could be providing there. Okay? So, again, it's a requirement in C. I say requirement that you have the return type as int. Like a friend said there, you have to have a return, an integer value returned. That's how the C designers wanted it to be. Okay? So that's why in all C programs, you'll find that is C programs conforming to the latest standards, you will have an int main, not like a void main or not like just main. You have to have int main. Okay? There are some programs from yesteryears that will just have, like when you go around Googling, you would just see main function. There is no int, right? Those programs are not compliant to the latest standard for the C programming language. And you should avoid writing programs that way. So when you're writing a program, know that you have to have int main. Okay. You can have a different signature of main. When I say signature, all I meant is either you can have int main like this without anything inside the round brackets, and there's another flavor of it, wherein you pass 2 arguments to it, and it's pretty standard. We will come to that when we do command line arguments. Okay. For now, I've explained to you the basics. Maybe I didn't tell you why I'm using double quotes there, I think. Yeah. So whenever you have a string to print, you put it in double quotes. Okay. Now, I'll stop here again, and you guys get to ask me questions if you have any. Which one?
Because strings are mainly used for sentences, right?
Right.
So why did you make the
Main function as names?
yeah?
That's a requirement by C standard. Irrespective of what you want to print, what you want to code, you will have a main function, and the main function will have a return type of int. That's how C language is designed. Again, it's a part of the standard, not how we want it to be. Int main is required, and it has to be that way. Any other questions? Yeah?
Why don't you have to actually call the function? So like in Python, you define your function and then at the end of the program you call your function. So
Oh no! Here when you compile the program, main is the skeleton and main is the engine of your program. So that's the starting point. Operating system will know it's a C program, and it needs to go exactly where it will exactly find main.
Okay.
So that's everything. All that magic is done by the compiler when it produces the machine code. Any other questions? Okay. Then what you can do is
There's a question there.
yeah. Sorry.
Okay, let's say you want to put another sentence
Uh-huh.
after and for outside the school.
Okay. I want you to try that. I'll give you a hint. You can do it in 2 ways. You can either do it in this syntax itself, or you can write in other syntax. So I'll bring the neater version of this code without all the explanation up on the screen, and I would recommend that every one of you tries this out. Sterling already has done so much C programming for a whole semester, so I'll not be even looking at him.
I did it.
How do you get it to where executes? Because right now you don't. Because I know you can change right? And like
That's for the permission. Okay, so now we can go back, creating the program. Let me show you a quick command.
oh okay.
You can type cat postcode,
Oh yeah.
and that will give you everything you want to see on the screen without going into menu. Okay, so that's your main program. So in order to run it, go to pilot. And because you're ahead of the class, I'll just click in here and put the command Python. This one is -4. Whenever you're compiling a C program, the program name is what? So to put that name. Please tell what's the name of the output file you want to create? No, that's the name of the program.
Oh, what's the name of the file?
Output file.
Name?
No. You can give any name.
Oh, any name.
Say first code. That you know what output is to run his first code. Space. First code. Enter. ls minus lcr. Save it by. Put a space.
Oh, yeah.
See the shape here? And do you see its color? So first code green.
Okay, because. Okay. So.
Slash. Perfect. Very good. No. You say
Oh, the first code.
Yeah.
No, it's not.
Oh. Aha, she got her aha moment. Now, is everybody with me here? Are you guys done typing the code? How many of you are still typing? Could you raise your hand? Okay.
No, this is.
So include what? Do we put the hashtag or no?
Huh?
Oh, yeah. You don't have to do it. I just.
Yes.
You type in.
It's not a comment, it's a.
Oh, okay. See, I understand.
Well,
Alright, is this what we're supposed to do?
yeah. Typed it. So you want to save it and exit.
Oh.
So once you're done typing the program, you have to save it and exit from the editor.
You want us to make it so we can?
Yeah. When you're done typing this, I'll progress to the next screen.
You don't need to.
So then we pull it up. Then first type yes. Now you have to save it and exit. So then you just do not slash.
Then rename it and then tell me.
You say enter.
So the first question is
Yes. Right. Enter. Control X. No. No. Let's check. Take as. Full space.
You meant like C after They are. Well, I was just trying to check.
Oh, yeah.
Oh, yeah.
Well, it's not lost.
Now you can type.
Right.
Oh, that's
Oh, that's what.
Yes.
Wait, is that old?
Okay, is everybody done writing their part? Okay.
Oh, wait, remember.
Okay.
No, I got it.
Yeah, say no when it asks you to say Control X. Yeah. Yeah, then you can always save it. After you save it, say yes. First.
I think you need to print out statements.
No. And I was wondering.
Yes. And then say control X. Control X. Say no. And now you have space. X does.
And then the word that just is supposed to name it and by it name it. This first one, it's like an alien. So you can just name it.
What is it? Like, for example. Yes, and there's a reason. Well, I have told you how to compile the program. Yes, I'll tell you that now. So you say control X? No. Yes.
Yeah.
You can always check what time you have. Watch. Say, program is there, but you have to have this as a .c program. So you have to change the name by saying MD space program space program.c. Yeah. Okay. Now seems like everybody has written it.
The second part?
Mine's giving me an error.
You typed it out?
Yeah, I typed it all out and checked what it just gave an error writing. First code that the text file.
Error? Why?
Oh,
So you do test.
I have no idea.
Oh, yes.
Oh.
I don't.
Control X. No. Okay. Wait.
Yeah.
Error.
For
That's not a compiled program. I'll tell you how to compile it now. That's just a program which you wrote. Okay. So there are 3 friends in the class or more. I think you all will also have the same program. Yes. Yes. Everybody who is getting the syntax error now needs to look at the next slide. Here. Okay, I hope everybody saved the file as firstcode.c or whatever your program name .c. .c is the extension your file should have. In order to compile the program, you will use this command, gcc or icc. And then you will provide the name of the executable after O. You will say -O first code. Here, first code is the name of my executable. You can name it anything, XYZ, whatever you want to name it. And then you give your program name. Here, the name of the program is firstcode.c. So if you type out the command, you will get an executable, and you run that executable. It's not .c. It's an executable that you're running.
What about even saving it?
I'm going to test that.
Saving? Say that again, please.
I was just asking if the year first for that C that's just what my test.
Test.c? Exactly. Your C file, whatever its name is, that goes here in place of firstcode.c.
That's just the compiler. What about? Okay, so.
You type the command?
So where do I compare it?
Here.
Here. So I just type that.
My mentor said, pick up on Unix.
First code, that's your executable.
Yeah, but I wanted to put the rest.
That you will do in the editor.
The problem is that it won't say anything.
Save it and then.
No, I think I get what he's saying. He's saying whenever we like try to save it, we can't. And so I was telling him to save it the first time, and then the second time, don't save it.
Exactly.
So change it to whatever you want, then save it, hit Control S. Then save it this time. Then save it, press enter. Then it'll give you that, then Control S again. And then don't save it. Do you get it? You already saved it for the second time. You didn't change it. No. You type
What's
in.
your goal?
You type in
What's your goal?
My goal here is the rest.
And then, okay, go to the code, nano, coordinates.
No, you made a mistake because you were just supposed to write first code. Just write first code. Don't. That's everything.
Let's see. Then go there, introduction, set line, type of code. That's what you want? Okay, now, insert. Yes. Save the file. No. Or just check.
And then don't enter the dot first code, just write the first code, the word first code.
I know that's okay. That's okay, not sure.
Oh, that's okay.
Yeah. Okay, go back to the program. You're trying to run. Now say control enter. Error writing first code. I have it's different. No, let's exit this. Exit Unix. Yes. Control enter. First code. Let me take it. Stop.
See.
Now we press escape. Look what I'm doing. Shift. Hold. Okay. Left say down, for right.
Shoot. Oh, yeah.
In the nano? Yeah, you can do it in the nano, but I don't know why your editor was stuck. I do not know. That's something I do not know.
Yeah, it refuses, he's right, it refuses to change.
So here, we need to control X. Sorry, right? You made a change.
You need to know.
Let's say, oh.
Yeah.
Why do you try to close? 6 lines.
Without.
No?
Yeah.
No? Now let's go back.
Times to control.
Yeah. I don't know what was going on earlier, why it was giving you file busy, but you saw me give it.
Whoa, it just deleted it. Because now I'm trying to change it to hands.
Oh, you see, this Slack is coming because even in there, it's just like escaping, so it's not like it's gonna get it.
I didn't even know until
You good here?
Not really. It still just says introduction.
You know what you compile it? Did you compile it? Yeah. The name here is supposed to go characters and the video running address with sports.
You're writing twice to fill without right version without
oh, you know what? Didn't for like C, C++, you had to like refresh it every time you did it? That's why it's not working. But how did you do that?
So everyone, just remember the basic steps. Wherever, what does this say? Compile the source code and link the program using a C compiler. If there are errors, fix that. And I told you that every time you are running into errors, you have to recompile your program. Whenever you are running your program, you are running an executable. And your executable gets updated when you compile the program. Till the time you do not compile the program, as in recompile the program, but make changes in the program, that will not go to the executable directly. You have to recompile and then run your executable again. And you have to repeat the process till you see the expected output. So recompile, run, recompile, run. Okay. So far so good. Any questions here? Yes. Dot C. You might want to do this minus after. Okay. This is how long files. That's an executable. What's the name of the program? Dot C. Oh, good fair stuff.
I'm just.
Okay, let's type it out quickly.
You know what was the other one? I don't
it's like it's not even that big. It's like it's just like the most basic way to learn.
No, you know that I.
Yeah.
Is that like okay, I got the picture. It's telling it better.
That's the only fun. I made a stronger thing. And then there was like I'm done.
I'm done.
I don't turn
Yes.
You can make all changes you want to that program. I use BI editor, so I can make that way. But it was in manual. Now, whatever changes you want to make. You gotta fix it. Okay, how many of you haven't gotten past this stage? How many are still working on first code.c?
The problem is you can't change it once you read it.
No, you can.
No, you can, but it refuses to say.
Let's see.
The same error.
Yeah.
You have to read.
We do it.
Yeah, I could do it. Oh yeah, because it does the same thing to me. Won't let you say.
Oh, yeah.
I get
Like,
to figure
so
out.
if I go into this,
They're like a lesser version.
okay, that's fine. But then it's basically the same concept about like they just want like great. Now I'm gonna have all these accidental typos. I go in here and let's say I want to say I don't know like what's that.
Oh.
And then
Oh.
control the right.
Oh yeah, I remember that.
Oh.
Control O.
That's
That's way perfect. Even maybe Nano just doesn't like see.
I don't like. No, I don't know. I don't know what it was. I don't know what's Nano's problem. I just
So you won't show it because I changed it.
I know, yeah. It's not saving me.
Because every time you hit no, it destroys when you change those.
Just jump.
Yeah.
So, oh. Tell you what. I don't know what the problem with this guy is. So VI is like nano, like VI. You go here. And in order to make changes, you have to press file. Okay, so you see it's what do you want to type?
I know it's
I like that game. Now you know to save that and you will press escape. Press colon. What can you remember?
Oh wait, can I?
I'm already tired.
Okay. And then to save.
Like, they got us with pictures and everything. Yeah, this one.
Okay, and then to insert.
like this. When you press escape, insert the move. Not press. Oh, shift. Because it's on top of this semicolon. Yeah. Shift. Okay. And then it's got to be or I guess that's what okay. So I guess okay, let's move on to the next thing. So you've tried GCC to compile the first program. Some of you tried ICC. So ICC is the command you would use if you have Intel C compiler. Okay. If you have the GNU compiler, then you would use the GCC command. And there are other compilers like PGI compiler. So if you're working with a PGI compiler, your command to compile the C program would be pgcc. And whenever you have to check what all options are available for your compiler, what's its version, etc., you can always say, for example, GCC minus help. Okay? GCC space, to be precise, minus help. That will give you the information about the compiler, the various syntax options, and the flags that you can use with the compiler. For now, we'll just be sticking with the plain command, GCC minus O output file name and the name of the program. Okay. In summary, what would you say did you learn so far now? Starting from a friend here.
I learned how to compile.
And what did you use?
C.
ICC? Perfect.
I learned the same thing, but I learned how to do that. I don't know how to.
The program?
Yes.
Like the program.
Yes.
And you saw the output?
I can redo it.
Okay.
I learned how to compile and back if you want to name it. Just really not the dots.
Okay.
They're not supposed to use the .c to run it. It's actually the test that you sent it to or compile or the first code instead of the first code. That's
Yeah, the name of the executable.
Yes.
Whatever you see after minus O is the compiler flag you use to specify the name of the output file or the executable. So if I have minus O ABC, name of the executable would be ABC. If it's first code, it's first code, right? Okay. And the name of the program file is the one that ends with .c. Okay.
Every time that you change your source code, you get recompiled.
Okay.
I figured out how to do it.
Awesome.
No, don't you?
Right? Should I go into this?
Oh.
Okay, here are friends in the back who are walking out. What did you guys learn?
So I learned that in ICC is for an Intel C compiler. GCC is for a GNU compiler. I have no idea what EGCC is for, but I know it's also a compiler.
I learned a different way how to save those files. And then we have
Okay. Okay, awesome. And that was your experience so far. But regarding the syntax of C programs, I told you that there are keywords and rules in C program. The keywords are, like one we discussed, return, okay? They have special meaning for the compiler, and you cannot name anything else with that name. As in your program, you cannot have a function named return, okay? It's a keyword. Then there are header files, right? What was the header file we included in the program? Was that it? Yes. And how did we include that? Hash include? Yes. And then why did we include that? Why did we have the header file stdio.h?
It's like a library for our functions that we use in our program for inheritance.
And which one did we use?
We used
Perfect. And then we have a function called main, and there is exactly one main function in every correct C program. And then we saw that there were a bunch of parentheses and braces in there. There was some punctuation like semicolon. And then there are operators like plus, minus, division that we will look into. So we have stuff like that and much more that make up the syntax of a C program. Now let us take a quick quiz. Fill in the blanks. Sterling gets 0 because he already knows everything.
I'll do it. I'll do the whole thing.
Okay. Okay, try.
the second line.
Okay, I can just do the whole thing.
Okay, first one. First one.
Okay, include.
Include?
Hashtag include.
Oh, hashtag include.
semicolon.
Semicolon.
The third space.
Wait, I got
Second one. Second one.
Curly brackets.
Second one.
Curly brackets.
In the last
And the
one.
second one.
The second one, last one, brackets.
Okay, and the second and the third one.
The third one is
Very good. That is awesome. Everybody gets 10 out of 10 here. Now coming to errors. Whenever you guys try to run the program, you saw some messages. At times, if you try to run the C program, like firstprogram.c, that's not an error message I'm talking about. That's something that you try to do which is not possible. That's not the error I'm talking about, okay? I'm talking about the error messages that you would run into when you would use ICC or GCC compiler. When you compile the program, you will get something like, okay, punctuation missing. And a friend here. What's the error that you got?
What was it called?
Yeah, it was an error. Those slashes were behind it. That was a type of a compiler error. And some other friends missed the semicolon. Somebody missed the pound. So those are the types of errors I'm talking about here. So in C, you basically have some categories of errors like compile time warnings. They are not errors. They are just diagnostic messages that the compiler gives you. It tells you that you're trying to do something which most often people do not do. The compiler does not clearly tell you it's wrong. It gives you a warning. Hey, like a friend here, if he tries to, let's say, walk out of the class, I cannot stop him. I'll say, hey, I warn you, if you walk out, you will miss the interesting part I'm going to talk about. I warn you, you will miss on all the excitement. Right? I'm not telling him he's doing an error. Right? So those are the diagnostic messages or warnings that the compiler gives you. Then there are some compile time error messages, like if you make a typo in your program, instead of printf, let's say you say print z. The compiler doesn't understand that. Or what if you flip the order of f in print? You say f print. There's nothing like that. That C understands. So those are the typographical errors. And let's say instead of pound include, you have dollar include. Poor guy will not understand what you're trying to say. Okay? Then, besides those compile time errors and warnings, there are some link time errors. I didn't talk about linking a whole lot till now, so let me quickly tell you about that. So there are two steps when you compile your program. In a sense, there are two guys that are looking at your program, compiler and linker. When you use a compiler like GCC, the two guys are there in one arrangement, like compiling and linking happens together. Okay, these two pieces of software, what they do is, compiler creates an object file. It's called a .o file. Then it's the linker. That guy takes that object file. It looks at the various libraries or other program files that you're trying to combine your code with, and it spits out the executable, which you then run.
Is the linker, you know, sometimes in C you could write blah blah blah, and you would write, let's say, plain first code.c, matrix.c. Is that the linker?
Mm-hmm.
Okay.
Yes, that is linking. So the link time errors would be if you're trying to build your program, but there are some function calls that you had in your program, but its implementation is missing. So the compiler wouldn't know that the header file you included didn't have the implementation. It's the linker that will detect that. So those errors are called link time errors, and you would see them if you have some missing modules or library files. Then there are some runtime errors, which we might not have a chance to look at in today's session, but just so that you know that when you would progress to doing pointers or pointer arithmetic, and if you do something like a null pointer assignment, you get runtime error. Or if we have a chance, we do arrays, and in case of arrays, you try to access something that is outside the boundary of the array, you might run into runtime error. Okay. Then there are bugs. Bugs don't essentially mean that there is something wrong with the syntax of the program. They essentially mean that you tried to do something which was undesired. Let's say I wanted to say bye-bye class, but I printed hi class. So program is not wrong to print the message. It's the intention. I wanted to say bye, and I said hi. That's a bug, okay? Unintentional functionality. Now, let's do a quick exercise. This file is very optimistically named error.c because I know there's an error in here. And you have to help me. Be my compiler, and you have to help me in finding the error. Yeah, how funny is that? Retrun, what's that? Compiler wouldn't know what that is. Okay? So first thing first, somebody said semicolon missing?
Yes.
Okay. So when you compile that program, compiler will tell you exactly that. Perfect. It says expected semicolon before retrun. It hasn't gotten to the point to tell you what retrun is or it's weird. It just says it expects a semicolon there. Okay. And then let's say we fix that semicolon guy there. Okay. You see that semicolon at the end of the line?
Yes.
Now we compile that again. What do we see now? It tells you. It first gives you a warning. It says implicit declaration of function retrun. And this warning is coming from the compiler. Okay? And then when your .o file is produced, that's produced by the compiler, and your linker tries to link it, it sees, well, I didn't see anywhere where retrun is defined. So this guy must have made an error. And then it bulks it. It tells you that undefined reference to retrun. Okay? And let's fix that. Now we have fixed that. Do you think all's well now? How many say everything is well with this program? Raise your hand.
Hold on, let me check my
Yeah.
first code.
Why are there spaces close to there after the studio and include?
That's an error.
Yeah.
Yes. Yeah. What happens is the spaces inside angular brackets make sense to the compiler. or maybe the preprocessor, both. They try to find a file whose name begins with a space. Isn't that weird? It tries to find a file name space stdio.h space, which doesn't exist. And that's why it complains. Okay. So far so good. Let's move on. How do you write comments in your C program? So in C, you can give or maybe write comments in two ways. First and foremost, why would you need a comment? Yeah, you know what you're doing. Yeah. So the comments can be multi-line comments, and you write a multi-line comment like this, like you see in green here. So you have slash and asterisk, which mark the beginning of the comment. Then you have asterisk and slash, which mark the end of the comment. And these stars are irrelevant. You can skip those. But suffice to say that you need to have these 4 tokens. Beginning slash, star, ending star, and slash. So that's the order. Slash star to begin the comment, and star slash to end the comment. Okay? And everything that you provide in between here is ignored by the compiler. It's a comment. It's just for your reference. Compiler has got nothing to do with it. It skips reading that step wherever you have this comment. Okay. Now, if you look at this program, what does it do? It tells you some it gives you some words of wisdom. It tells you that braces come in pairs. You cannot have a round bracket, right? If you read the message that I'm trying to convey here, you will see that each of this is true. Comment tokens come in pairs. You have slash star and star slash, right? All statements end with semicolon, true. Every program has a main function, and C is done mostly in lowercase. But for your variable names and a special file pointer declaration, most of the stuff that you do in C is all in lowercase. So far so good. Is there any error with this program? What are the semicolons? Yeah. So that's not an error, but that's a bug, right? So if I run this, I'll get a clobbered output like this. All statements like that. But when I wrote the program, my intention was to have all of those lines on a separate line. All of those comments on a separate line. But that's not what I got. What do I do to fix that? Our friend has an answer there. \n. You just fixed that. Yeah. So I'll just put slash ns here. So slash n is going to progress my output to the new line. And voila, everything is fine with the program. I like the way it will look after I run it. Okay. Now, besides using a slash star and star slash for the comment, you could also use 2 slashes like this. Okay. This is another way to specify a single line comment. Again, you can have multi-line comments, as in you could have multiple lines commented out at the same time. If you use this token above, which is slash star, star slash, okay? If you want to have just one line commented out, you can use just this. Or you could also use the same token, but you just end it on the same line you started it. That way it's one line comment, like this one. So this is a multi-line comment right here. This is a single line comment with slashes and stars. This is another example of a single line comment with both slashes. Right? So far so good? Okay. So now when I print this, I like the output. And now what you might want to do is, when you go home and you're still interested in learning more about C, then you might want to go to c++.com and read more about printf. So I showed you just one way of printing a statement or printing a string using printf's function call. You could be printing integers or decimal values or hexadecimal values or octal values using different format specifiers. And you'll learn more about them by going to this link. Okay? Okay. Now C has some reserved words, as I told you, and those are called keywords. What are the keywords we have already seen? Main. Who said main? I'll give you 0. And the reason is, no, whenever I give this thing on my quiz, 98% of my students say main. You're not alone. Actually, 99%. Only 1 or 2 students take this liberty of not saying main as a keyword. It's a trick question, actually. Even I used to think that main is a keyword till some point. Okay, main is a function name, right? But main is not a keyword. It's true that you cannot have any other function with the name main, as in you cannot have 2 main functions. You ought to have just 1 main function. And it's very easy to get deceived. That's why I said it's a trick question. 99.9% people, if you ask them in an interview or give them a test question, they will pick main because it seems like it's a keyword. And to me also, till maybe a large part of my life, it appeared as a keyword. Till I actually went through the C standard or maybe the book. I started programming just by hearing or just by seeing what other people were doing. That's how I picked up the language. And never till the point I actually read a book and I saw, wait a minute, there's no main in here in the list of keywords. Then I got more inquisitive and then I started digging more and then I learned, oh, that's because main is not a keyword. And the only keyword we have seen so far is
Return.
And is there something else?
Return.
And?
Print.
No, that's a function. That's minus 0 if that exists.
Wait, did you say int?
So it would be int and return.
Int and return, yes. Int and return. Okay. So in C we have various keywords and we have seen 2 of them, int and return. There are a bunch of others. And I've tried to categorize them under few categories. So there are some storage class specifiers like auto, register, static, extern, typedef. And I do not think we'll get a chance to look at any of them. Then there are structure and union specifiers. And their keyword for specifying structures and unions are struct and union. I'm not sure if we'll have time to even look at that, but we'll see. It's still 2:30. And then we have enumerations in C, and the keyword for that is enum, then type specifiers. Char, double, float, int, long, short, signed, unsigned, and void. Okay. There are some primitive data types, as in the basic data types, and they are int, float, double, char, and you can qualify them further by saying signed, unsigned, and there's a type called void. Okay. There are a lot of details into all of this that I'm skipping for now, but know that these are the types that exist in C. Okay. And then there are some type qualifiers. That is, if you're working with, let's say, circles. Okay. How many of you know how to calculate the circumference of a circle? And what's the formula? 2 pi r. If you 2 pi r. And what is pi? What's the value of pi?
3.14.
Bunch of numbers repeating? Yeah, 3.14. Okay. Does the value of pi change ever? It's always a constant, right? In order to have your program variable such that the value never changes throughout your program, you can make that variable a constant variable. So if I'm writing a program, I know that pi will never take any other value. I do not want it to be updated even by mistake. I will make that a constant variable. And the opposite, or maybe not quite an opposite, I mean, slightly different thing is volatile. Volatile, as the name suggests, you're telling the compiler that I have a variable whose value is going to change pretty soon. So do not think it's the final one, something to that effect. So we'll not be looking into volatile or maybe anything else. we might have a chance to look into constant. Okay, control structures. We have if, else, do, while, for, break, continue, blah, 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 all that stuff. But before I even tell you about those, let me tell you quickly about control structures. How many of you have done programming before? Okay. I'm surprised. You are doing so well, and you're...
I did like baby programming.
But still, I'm surprised. Wow. So pretty much everyone? Okay. So you know that when you write your programs, you have loops, for loops. You have conditionals like if-else, right? So you have stuff like that. Those are called control structures. Okay? And then there are keywords for writing your control structures. And that's what this class stands for, control structures, the keywords that you use for creating your control structures. Then you have operators, and size of is one operator. And this is another of my trick questions on the exam. Whenever I ask people, dash is what is size of? And I give them options, and they'll say a function. It's an operator, which looks like a function, but it's actually an operator. So that's another place where maybe 99% of the people will say that it's a function, but basically it's an operator. So there are deprecated keywords, which are as in not used much, or their usage is discouraged, and there are fortran and entry, and there are others like ASM, bull, friend, and inline. Now, friend and inline, a C++ programmer would know come when you do C++ programming. Have you dealt with those? Friend function, inline function? Okay. So that's from C++. So that you do not name your variables or functions as friends or inlines and then run into problem during the compile step. These have been made as reserved words. Okay. Now let's look into variables. Okay, why do we even need that? So the first tiny program that we had, all it was doing is printing a message on the screen. Now you think about it, why would I want to write a program? There are n number of reasons why. I could be programming my remote control for the TV. I could be writing a program to move my robot. I could be writing a program to compute the product of two matrices. There are n number of possibilities why one would need to write a program. So just printing the messages on the screen is not the purpose, right? So in order to do something meaningful, we will start with variables. Okay, they are information storage places in your program, as in place is not in the program, but the program is requesting for a storage place from the operating system. Okay, so when your program runs, there are some places in the memory where the values of the variables or maybe the components that you're using in your program are stored. Okay, and that's where variables come into picture. They are information storage places. Compiler makes room for them in the computer's memory, and they can contain, depending upon their type, integers, strings, numbers, etc. And their values can change during program execution, unless and until it's a constant. The value of a constant doesn't change. Okay, that's an anomaly. Well, we make an anomaly. The whole purpose of having a variable is such that you're telling by its name that it's going to vary from one step to another. That's why it's a variable, right? When you make something as a constant, you're saying its value is not going to change, but still you have to declare it as a variable. You have to create some space in the memory for the so that the value can be stored somewhere. Okay, and then the variable must be initialized before they're used, and we will look more into that after this boring discussion. So there are two types of variables in C: built-in and user type. User-defined. And then there's one more type called derived. So the built-in types or the primitive types are what we've already seen, like int, double, float, character, okay? And then there are user-defined types like structures, unions, enumerations. And there are derived types like arrays. How many of you are familiar with arrays? Good. Middle class is familiar with arrays, okay. Okay, how many of you are familiar with matrices? Who is not familiar with the matrices? Matrices, vectors. You know matrices? Okay. That means I do not need to explain matrices. Okay, so then there are pointers. Probably will not get to the stage of pointers, but this is just for you to know. And out of this list, we have already used one data type, which is integer, when we were defining the return type of main. And just so that you know, the value that an integer can hold, okay, again, when I say value an integer can hold, I mean the memory space created for an integer, okay. Going back to this description of variable, you see variable, what is a variable? It's an information storage place. So when you create a variable, a particular size of memory is set aside for storing values. So when you create an integer variable, depending upon your computer, like if it's a 16-bit computer, you might get this much space in this range to store the value. Okay, you can store as low as -32768 or as high as 32767. That's a value your integers can hold. If it's a 32-bit computer, it's this big guy here, 21474834647. These many values can go into an integer. Okay, and it goes in both directions, plus and minus. If you want, you can make an integer unsigned, wherein you don't care if it's negative or positive, you just care about the value. So then the range doubles. So you just add this to this guy. That's the total range of the numbers that you can store in here in an integer. Okay. So that's about a variable, as in what variables are. Again, they are information storage places in the memory, okay, that you need while you are creating your program. And then each variable would need to have a name. You cannot have int 3. No, that wouldn't work in C. You have to have a name. Let's say int x, int y, where int is a type and x is the name. Okay, this name is the identifier that distinguishes one variable from another. And note that keywords cannot be used as identifiers, as in you cannot have int return or int long, or maybe int something else, int struct. Struct is a keyword. You cannot declare a variable with the name struct, okay? So let's look at how we declare variables in C. So if you look at these two examples, I'm trying to declare a variable of type integer, and the name of the variable is number1. And do you see a semicolon at the end? I say int number1 semicolon. If I have to declare a variable of type float, float again is a decimal number, as in a fractional value, which in single precision. So in C, you can handle both single precision values and double precision values. For simplicity, you can imagine that double precision values hold much more places. You can hold much more places after the decimal in double precision, whereas in single precision, you can hold only so many places, let's say 4 or 5 or 6. I don't know the exact number, I forget. So the number of values you can store, the length of the values you can store varies with the precision. There is float again, and there is double. Okay, and how I can find out the size that is allocated from my integer or float? I can use the size of operator that I mentioned previously. So if I think I have a program that will help you determine the size of the variables. But if you use the operator size of on the variable name, you say size of any variable name in round brackets, it will return the size in bytes. So when you run that program, you'll know that for integer, it takes 4 bytes. For float, 4 bytes. For double, it takes 8 bytes. You get much more memory, and hence you can store much more values, okay, in that big size. Okay, now this tells you how to declare two variables of type integer and float. Now what is 2.37? An integer or a float? What is 2.7777777777? And I stop here. Double, maybe. It's just too big. Pretty long, pretty long. I didn't even keep count of how many. It's not that it can go till forever. It's that it can go till forever. It can hold up till 8 bytes, but definitely double the size of float. So that's what how you would have like a float. And then how do we have multiple variable declarations in one line? That's what the second example shows you. We are declaring 3 variables, x, y, and z, of type integer, and all using a single statement. Okay? And again, some data can be signed or unsigned, and you can use type qualifiers like that. So you can have signed types which can represent both positive and negative. That's the default when you declare an integer. But you can say unsigned int. You can put unsigned in front of int here. That will give you, if you make an integer unsigned, you cannot represent negative values with that. Okay, so you can have unsigned integers, but you cannot have unsigned doubles in C. Doubles are only signed. This is just superfluous here, because by default it's going to be signed. So let's look at this example. Here I'm declaring a variable and also initializing it in the same line. I'm saying int x equal to 10. And let's look how we initialize characters. So characters are single values. Okay, string, like introduction to C, was made of multiple characters. Okay, when you have just one character or alphabet, that's stored in a character type of variable, char, and the name of the variable is x here. I'm saying char x equal to single quotes a. So a is the character I'm storing in x, and I need to have single quotes around it. What's the notation for, I mean, when I passed string to printf, what type of quotes did I use there? Double quotes? Yeah. For characters, note that it's single quotes. And then I have this double x. Not how big it is, it's still e to the power 23. That's how much you can store, probably around in this double value. Then I have float x, it's 10.11. Okay, these are just examples to show you the type of values you can store here. So in C, you can use e for the scientific notation if you are dealing with very long values. And note that when I was talking about reserved keywords and I was telling you about data types, I told you about void. Void is a data type, a valid data type, but you cannot declare a variable with the type void. You can have functions return void as in nothing, that's a type of the function, but you cannot have a variable, let's say void x. That's not permitted in C. The whole purpose of having a variable is telling the compiler to set aside a memory for you to do some computation in your program. And that value is going to change over the period of time. But if you're not specifying the size, because with int it knows it has to reserve 4 bytes. With double, it knows it needs to set aside 8 bytes of memory. With void, it will have no idea. So it cannot reserve memory for you. Okay? That's why void cannot be used to declare a regular variable. It is used as a return type of function or as an argument to a function, or when we do pointer arithmetic. Well, we won't do pointer arithmetic, but if you do pointer arithmetic, you will see more usages of void there. There's something like a void pointer. Okay. Let's look at this more elaborate program. Here we have variables, we have variable declarations, we have assignment of values to variables, and let's see the purpose of the program. So the goal of this program was to have a variable, age, set it to 10, and then print the value, and then update the value. Age is a variable. It's not something that is fixed. I can always change its value during the course of execution. So let's say I set the value of age to 20, okay? Then I'm updating the value again here, in the third update here. Age equal to age plus 20. Then I'm printing it again. Basically, that's what I'm doing in the program. I assign a value, I update it twice, and I try to print out the value at each step. Okay? Now, let's start from here. What's the first line? No, the first line in the program, hashing clear. That is because I want to print something. Okay. What's the second line of the program doing? Like this guy here?
I thought we just had a discussion about me.
So what is it doing? Why do we have int main there? So can it be test, like int test? Can I have test there?
I thought it's always said.
It's always got to be main. You ought to have one main function in the program. Yes.
Scared me.
I scared you.
Yeah, I was like,
Okay. What's the third line? Perfect. Thank you. And the name of the variable is? And the type is? Perfect. What's the fourth line?
You're giving the variable value of 10.
Yes. And what's that guy in the end? Semicolon? Why do I need the semicolon in there after 10?
If you didn't have a semicolon, it would give you an error.
Perfect. Yes. And the
one, we have printing initial value of age is 10 at this point. I use %d just because it's an integer.
perfect. So Sterling just mentioned what that %d guy is doing in the print statement. So you see there's some stuff inside double quotes. That's a string that gets printed. But there's also a value that I want to print. And the value is that of a variable. So in C, when you're printing a variable, that's a syntax you use. You say, like this is what you want to print, like age, that's the variable. But it has to be printed inside the string, okay? So you will have %d, the format specifier for printing integer values. Here D stands for decimal, okay? It's not the decimal numbers we were talking about earlier, like the fractions. It's any integer value that you want to print, you have to use D for decimal, for printing the value. So when your program runs, this %d gets replaced with this value in age. That's what happens here. Okay. So %d is the type specifier that we provided inside double quotes, and its value gets updated or replaced. %d gets replaced in the string with the actual value of age, the value that's in the variable age. Yes.
The variable age, which the value of 20.
Yes. What do we do in the statement after that? Right. So here, what's the %d guy doing? The %d.
Not sure what's the first time.
Okay. So the %d there is the placeholder for the variable that I want to print. Because you see, it's a string that I'm trying to print. If I do not have %d, then everything inside it gets printed as is. When I specify something after %, the compiler knows I want to print something of the type d, which is an integer.
That's what it's trying to do.
Yeah, exactly. Okay. Perfect. So what would I get if I run this program? What would be the value of age by this time? Perfect. Okay. Now what's the next printf statement doing? Okay. And what's %d doing there? Yes. Very good. Yeah, because we're trying to substitute something in the string with a variable's value. So that age will get copied there in place of percentage in the program class. Okay, very good. What's the last one? Yeah. Yes. So return 0. But this is 0. Take an integer. Can I have 10.12 there in place of 0? No, yes, I cannot have that. I always have to have an integer value after return. Okay, very good. So for the next example, our friend behind in the second row, our friend, no, in the second example, I'll start with you. Okay, so when I compile and run this program, this is the output I get on the screen. Initial value of age is 10, an updated value of age is 20, and the new updated value of age is 20. Like a friend at the end of the row, she asked a very good question. She's like, if we say age equal to age plus 20, does the previous value of age gets down here? And that's the case, yes. Whatever age is before this line here, like age was set to 20. So we get 20 here. And again, we are storing the value in age. We use the value of age in computing the updated value here, and we store it back in age. Basically, that's what is going on here. And when I compile and run this program, this is the output I'll get. Okay? Oops. That's the end of this set of slides. So my favorite book is this one, C for Dummies, by Dan Hookin. If you just Google it, it's a very cute book. I think that was not the first book I read, but I wish that was the first book I read. Because I started reading, when I started learning C, digging more into it, I started with like maybe a more comprehensive, fat book. It was so comprehensive that I felt like tearing it into pieces so that I can digest a piece at a time. It was so boring. But C for Dummies is written in such an excited manner, as in a humorous manner. I love the slight sarcasm that's there in the book when the guy tries to explain different concepts. So you might like that. And this book, C Programming Language by Cunningham and Ritchie, those are the guys behind developing the C standard, the first one. So that's a classic one. It's a thin book again, maybe this big, not too overwhelming. But this gets my vote, the highest number of votes, like C for Dummies. I love that. So you might want to check that out if you want to learn more about this. And let's go to the next set of slides. Oh, I have no idea how to bring that up. Which one?
I thought this was happening on Windows.
You were wrong.
Didn't you hear John when he said that only one Mac computer is used as for Windows version? But they used two.
They use like
No, they said the most common was supercomputer.
I have no idea how to bring this up.
Yeah, thank you, Arnold.
Linux was the most, but how come Windows had more than a Mac? If Mac was so big, and they would have made so.
Maybe what I'll do is I'll not use the slides. I'll just do an impromptu kind of thing.
Let's ask.
So let's do.
No.
I think someone turned it down. Yeah, go look at it.
Okay, so let me just. Okay. So let's write a quick program. Everybody gets ready to write a program. Your task is, let me write it down on the board. Mm-hmm.
That isn't really cool. It's just
There's no reason. I mean, of course, there's no reason to be unhappy. God has blessed me with a good job. God has blessed me with a nice husband, nice family. I'm happy. That's all I have asked for from life. Okay.
He wants to have.
I'm saying, I'm trying to get over
So let's do this. So let's write a program in which you declare a variable of type double. Okay, and let's call the variable pi. Okay, and let's set its value to 3.14. Then what you have to do is, you have to have an arithmetic expression in your program which says x equal to pi plus 2. Then, now let's do circles. Let's do 2 pi r. Okay. So we are trying to print the circumference of the circle. That's the goal of the program. Print circumference of a circle. Okay? And the formula for finding the circumference of the circle is 2 pi r. This is the pi value. And its value is 3.14. So 2 multiplied by 3.14 multiplied by r for the radius. Okay. So now you know that you want to print the value of the circle whose radius is, this is what I give you, the radius is 2. So now you have to write a program that prints the value of this circle that has radius r set to 2.
Oh, we're setting the radius to?
Yes. Yes. Start off by writing whatever you can think of. I'll be coming around and seeing how you guys are progressing.
Is Pi already? I forgot. Pi is already in the main library. Or
You should declare that. Declare a variable pi. Yeah, and say that I'm set it to 3.14.
EOUBO. Yeah.
Thanks.
What do you do?
I don't know.
Okay, so that's your question. Write a program to print the circumference of the circle with radius 2, and your value of pi again is 3.14, and the formula for calculating the circumference is 2 multiplied by pi multiplied by r, where r is 2, pi is 3.14. Okay, so you have to print this value. And I'm pretty sure you'll run into one problem, not a problem, one question when you try to print this value. Because so far, I have only shown you how to print strings and integer values. So for printing the value of this guy, what is its type? First you have to think, what is the type of this value? Float, yeah, very good. So when you declare the variable, you have to declare the float variable, very good. When you're printing a float value, the type specifier that you have to use is %f. Like you had %d inside double quotes for the printf statement, you'll have %f instead of %d. So just start out writing the program or maybe developing the algorithm. I'll visit you and ask you where you're stuck.
change the type to version the name
It's good. Just that when you fill the value. It's okay.
I'm using
Beautiful, yes.
Oh, no, sorry. I don't know what I'm
But you took double, that's good enough. It's double. Okay. Guys, there must be some confusion. So I must have said that you can take pi as a double. Well, you can store pi, this value 3.14, just press 1 in float as well. You can either use float or double, doesn't matter. But while printing, if you're printing as a float, you have to use %L. When you're printing double, you have to use %LF, long float, which means it's double the size of the float. It looks nice. Then you can have a double. Yeah. And but you do have the value that's already. So you just declare it there. That looks good. It's double there. I'll put the previous program on the screen so that you know the syntax of syntax. If only I can figure out how to bring this guy up. Sure.
What reason double %?
I don't really know what I'm doing. You are doing awesome. This looks great. This looks great. Very good. It's perfect. Just that you need F here. Oh, F. I thought. Oh, wasn't L. L. Yes, after L. Yes. Okay. So now you have to say. Remember that I.
So it's all for
We know why. Let's go back to this. Let's go back to this guy. Oh, yeah. Now this guy I don't have brought H up. Oh, that's right. See? Oh, okay. And then that's yeah, that's right. You got the rest of this.
It's like everyone else knows that we have a
This is comma. See that there? In the print statement after the string, there's a comma, and then the variable.
Okay, but I have like my.
Yes.
Okay, then I know.
Thank you.
Yeah.
Okay, awesome. You got it? You are in the right, on the right track. Situate, well, easy twice. What we have to do. Doesn't have to interact. Equate it.
I remember,
So yes, for certain friends, very good. Yeah, that's good. That's it. Both, well, in the formula also you have to, in the radius is less. Multiply by 5. You declare this value here, but of course there's no semicolon in the next time. But that's
I knew I was.
But this one is English. Multiply. Yes. Now, you got that formula right, but you haven't said the value you have read, but the radius. So you have to come up. Yeah, equal to. Now, wait, oh yes. What do you have up first? So you just separate them and we find the value.
Yeah.
No, after this, after you calculate the values. Okay.
You're saying print the value of the moment. You said after.
Yeah, come bring your cursor here. After this semicolon. Or you can use, or you can use type the content statement. Because still you have your content statement. It's not going to be you can say Mike's levels value.
No, well, and then double it is
Yeah,
so I
just well, I need something like there, and I kept doing like after, and I kept it's the capture, and then we go just like
But now we're painting a full value. So I have to use F and this string is to be in. That's why I saw that's why my answer because you need to tell what to place this guy below. No, C. Well, that's what you're saying. Comma C. It's okay, you can have, we're going to close it. We close it on target. And simple. Yeah. Almost there. Almost there. Just. Yeah, just. Oh, actually.
We have to,
Yes, that's how you run it.
Oh, okay. But you did 2ls minus LPR, but you did for us. You created a file with circumference of the program, a C program, that does not have a dot extension. So, how can you do that? The command is md. Type md. Oh, now you see say ICC -4. Wait, what do you want the executable name to be? Because with the executable, you don't give this extension. You can just call it circumference. Yeah. Oh, sorry. Now you give the file. What are you Is everybody done with this tiny circle program? If you have this program and you want to change the real six, then you can do this as oh, so that you can yeah, that's
honestly, I just see that.
Yeah.
It's just like slightly.
Here, the result is 4.500. That's a this floating number is floating by. That's for the prompt. The last prompt is your oh, yeah. Oh, you're yeah. Yeah, you need to yes. You have to do that's what I hear about the like.
I was gonna say what else. I'll think there's too much.
The whole point of this is calculated circumference, and this is what you want to print. This is just a string, just text. The real value will come and sit here. For the program to know what to put here, you tell it that this is the guide. Oh, you know what? You never named your city folders. So do the C. So that go back there. Then here you have to specify the name of the outsource file. Circle or seeds are input file which goes into the that's good. Yeah. Okay, now try can you add circumference and it's because and some page might have oh, you call Paris Eat friends. Here is it. There's an extra. Got it? Are you good here? Yep. Okay. Do you guys can write C programs now? You wrote 2 programs at least. Okay, now let's try the first program. We still have about 40 minutes. Sure, sure, sure. Okay, now let's do a program on calculating the area of a square. How do we find the area of a square? Area of a square, what's the formula? This is my square, and it's length is L multiplied by L?
Yeah.
Very good. Okay. That's a formula for calculating the area of the square. And then your goal is to write a program, this guy, SQUARE. So now if you want to calculate this area through a program, and then you have to have what? You have to know that you have to have a variable L declared, okay? And you want to know its type. You can take that. And you want to set it to 10.10. Okay? To find the area, write a program to find the area of the squares and then print it. Print the area of the square. Yeah? There is. Okay. There's a header file called math.h. Like just like you include stdio.h, you include math.h, and it will give you access to a lot of functions like square root, power, and then you can find logarithmic values and all that stuff. It's available in math.h. In type 1. What is the function that you want to do? A square. You have square root, but I don't know if they have square. I'm not sure. You can use power of 2 though. You can say something like this. Yeah, power. And you can raise the number to 2, like this. Yeah. You can do that. 2. Okay, once you're done with this teeny mini program, I'll tell you more about interesting things. Is that you know how to print, you know how to declare variables. By the end of this exercise, at least you will remember that.
For double, we can use Ruby LF instead of %d.
Yes.
Okay.
What's an LF for printing?
Okay, I'll put an example slide there.
Change.
Oh, yes, yes.
How many of you are done with the second program? 1, 2, very good.
So that's using the double L. And then you said it yields a template.
Oh, the command to make that. Oh, so that's it. MV.
Or it was something. Okay,
And five that you want to.
so every time you're going to declare a variable, and the double has to go ahead. And then we end up with double and then call it whatever the function whatever we want to call it. So then, oh, go up. Sorry, I forgot to tell you. What?
Very good.
Oh, actually, you could do that too. I didn't know that we wanted to power.
Of course, too.
Then, you do your print statement, because you want to print out your results. Oh, I turned my area.
Oh no. Just one tiny guy. That's hash. Hash, a quote.
Oh. That's not honestly,
Got it?
I think it's the same in previous class.
okay.
So
whatever you
you
want
get the
to
first
write,
part in,
and then parentheses.
and then you gotta define your variable. So, yeah, so I call mine set.
Yes, that is it.
Was that
Define your variables.
I think there's like
Given saying that's doing int.
your hand.
Name of your variable, you gotta double the name of your variable. So for me, the variable name was time, so you double
And numbers.
and then you
Like
set
your hand
what your
funny.
size, you have, it's like, it's just the same thing as up there. If you look at that,
And then
it's
don't
just the same. Except for, so like, you define your variable,
I think we fixed it.
and then print, but then you have to calculate the area. So I got it.
Hold on.
Just like falling one. But and then I just.
How many of you are still working on the second
I think
exercise?
Yes.
I know.
So I think when you would type
Here,
that,
here.
that would be much easier.
solve for the bigger terms. Instead of doing like side text, we just do areas and
I'm trying to figure it out, but I don't want to.
We are on the right track. Maybe I'll just give you one hint. This
L multiplied by L.
You'll have maybe 3 or 4 more minutes. Guys, hurry up, finish this up so that we can move to the next part.
Oh, sorry, I was wondering if I could have it.
Nice! Yes, you can. That is awesome.
Oh, but I think the ones that
Control X.
No.
go back. Okay, so. Backslash this thing. Okay.
Oh.
I'm sorry. It's and yeah. Oh wait, so you this. What is that? Like you could do. F and then backslash. But no space. And then afterwards, comma. But that's comma. And then your comma.
No.
Then semicolon. Yes.
You're almost there. Maybe it's just that.
This is
L multiplied by L. So you have to declare the variable in table, double A equal to. If you don't want, that's how you look at it. You initialize this value. No, it's a L equals to.
So we're looking at use the coal, or no, I'm sorry.
That is good. You have L.
That would.
So it's a variable name. No, he actually has alien. But he looks like the guy. He looks like our guy in I don't know. Like, you know, that guy was aliens. What's it? Yeah, I feel like it's
Like literally weekends and weekdays.
Sometimes you really do wish like also like having an app people.
You really want to like a variable, like start walking like that. I wish there's so many people. So I just want to ask you that then you can say hi.
No, ours is not like hi. Each person you're walking by.
Yeah, I use it.
There's only like one, two,
We're all the most
three,
popular kids on campus.
Are they walking down the types of like anytime mythology?
Yeah.
Oh yeah, it's it looks cool like 2 weeks of it. Like, oh,
Yeah, but there's like all these free t-shirts.
Like, when I tell you this.
Yeah, that's cool. Yeah.
Free t-shirts, a free t-shirt.
okay, sure. It'll just die and look like something else.
And like, they would give you and you first.
Cool.
Okay.
Because yours is like
So now you have written programs to print values of floats, long values like doubles, and you have also written a program to print integer values, right? Just in case you want to print long integers, which is like an 8-byte long integer, then you would use long double, okay? And in order to find more format specifiers like those, that's a link I recommended earlier. Go to c++.com and look for format specifiers for printf statements. And there you'll find a bunch of other things that you can do with printf statements. Okay, so congratulations to everybody for progressing this far. Now let's quickly move forward to a few more topics. We just have about 25 minutes or so. So, so far, we declared variables of type int and just printed those. Declared variable of type double and printed those. Now, there's something called as typecasting. By typecasting, you can make a variable temporarily look like another variable. So if you have, let's say, an integer value, you can print it as a double value. If you have, let's say, a character value, you can print it like an integer value, and so forth. So in order to type, this is called typecasting, as in changing the type superficially of a variable, okay? So in order to do that, all you do is put the type that you want to cast in front of the name of the variable, like we are doing here on the statement. So in this program, again, first line should be clear by now, hash include stdio.h. Then we have int main, and then we have a variable where a of type double, and its value is set to 65.00. Okay. Then we declare another variable where b of type character. Okay. Again, what can a character hold? Any example? Like what can I put in var b? Example, I'm just.
Oh, he's examples.
1. You can put 1 as character, but how would you put that? Yes, single quotes, perfect. Yes. So that's like a variable a is like a double value, and then trying to put char in front of it. Okay. Now, are you guys familiar with ASCII numbers, IEEE format, and all that stuff? Okay. So the ASCII value 65, this guy 65 stands for A, capital A. Okay. So when you put char in front of var a here, like in this statement, Look, let's go one by one, like one line by line. So here I have a variable var a set to 65 and its type is double. Then I declare a variable var b of type character. And I set the value of var b to var a, okay? But note, I have char in round brackets in front of it. This means that I'm typecasting var a to look like a character. Though it's a double, it will appear like a character. And when I'm printing it, so here I'm printing like var a %lf. So whatever the value of a, the double original is, that gets printed. Then I say var b %c. So whatever the character equivalent of var a is, like here, that gets printed. So I get capital A. Yeah.
Why do you have to define the variable in one line and then set it equal to the character value of var a?
Just to show typecasting. I could put it in one statement. That will still work. So that's how you do typecasting. And then in C, there's also implicit type conversion that happens. So when you have a value like integer, and you say like int x equal to 10 in your program, and you try to print it as a double or a float, its type gets promoted. So instead of 10, you get 10.00 printed on the screen. On the other hand, if you try to print a double value, let's say 12.10, 12.10, I mean, if you print that as an integer, 0.10 will get dropped. It gets truncated. Okay? So there's this is called like implicit type conversion. So you have to be very careful when you're printing values or using them in your programs that such things happen. So look at this program. Let's see what's going on in here. You have a variable a, var a, of type double. Then you have an integer variable called var b, which is set to 2. Then you have a double variable var c, and that is set to 9.34. And what am I doing here? I'm saying var a equal to var b. Okay, what does that mean? A friend in yellow shirt. What does this mean? Var a equal to var b? Any guesses? Yeah, and what would be the value of variable a? Var a? What is var b? No, what is var b? Here. This guy. No, I'm asking what is this guy? What is var b at this step? 2? It's 2? Perfect. So when I say var a equal to var b, I'm saying var a equal to 2, right? Okay. What's happening here? Var b equal to var c. And what's the value of variable c? Perfect. So you would expect that var b will have 9.34. But what's the type of var b? No, integer. So when this guy gets printed, it prints as 9, not 9.34. Did you guys catch that? Okay.
Wait, no, I did not catch that. What?
Okay, let's go one by one.
Wait, how come? What? Wait, how come? Var b is it because variable c is the last variable, so it's like no.
Which one?
It's doing the same thing. That's why I only get 9 instead of
No, oh wait, go back to the code.
Yeah, here's the code.
No, the other.
Oh, the other one? Yeah.
The other two are actual doubles, percent LF, that's why those ones have decimals of 3.
Oh.
So here, what you have to remember that var c is of type double, okay? It's type double, and var b, what is its type? Its type is integer. You're trying to put a double value into an integer value, okay? And then that's where you would lose the precision.
For our test, just because you're tricky I feel like for that teacher, that was like really get tricky to say.
Yeah. Yeah. Ask Sterling, but he topped my class. He was amongst the top few, so he wouldn't say that.
That is so sweet.
She's never told me that, so I'm feeling really good about that.
I give you a great recommendation letter.
I know. Did I ever send you a thank you email? Thank you.
Thank you, my pleasure. Okay, that's very kind. Now let's look at this program again. So var C again. Now do you guys catch that? Var C is of type. What's the type of var C? And what are we doing by saying var B equal to var C? Trying to put a double value inside an int. At the very beginning, I told you guys that integer is 4 bytes long. Doubles are 8 bytes long. Imagine you're trying to fit in a big suitcase inside a small one. Either you'll squish that, or break that, or do whatever. But can you fit a bigger suitcase into a smaller one? Yeah. If you try it, that's what will happen. You'll lose something. So that's what is happening. When we put var C in var B, we lose the precision. So the 0.34 part gets dropped. It gets truncated. And this is because C does implicit type conversion. Okay? So whenever you're writing a C program, be mindful of the data types. When you are expecting to store a double value, make sure the type is double. Make sure you're printing a double value. Many of you, not many of you, 2 or 3 of you, I was looking you were writing a program, and instead of printing a double value, you were printing a decimal, the integer value with %d. That's where you were not getting the right output. So when you change %d, you remember you were getting the right output by changing %d to %lf.
So you can go from int to double though, right?
Perfect. There's no loss of precision. There's type promotion there. So if an integer is 10, you will get 10.00. Yeah. Okay. That's what is happening with var A here.
I have a question.
Mm-hmm.
Because now that variable b is equal to 9, if you were then to change variable b to a double, would it still be then 9.000?
If we change var B to double, like up in the program?
Well, like, because you know how it got truncated right now? If you were then to change that variable
to %lf, my compiler will complain. If I just do this, like
the 3, 4, would it come back?
It wouldn't come back, but on top of that, when I say like var b %lf in the printf statement, the compiler will not like it. It will tell me I'm trying to print, maybe it will just be fine. I'm not sure. I think it might either complain or it will give you some warning message. It will tell you that. A warning, I think it will give you a warning.
Yeah.
A warning? Did you try that?
I remember trying to do something like way back, and I think it gave me a warning.
Or you guys can just try it out of the program. Just change the type, just print an integer value with lf. It will warn you by saying that you're trying to print a value in a different manner. But it will not give you back points.
Okay.
No pressure. Okay. Now talking about the scope of variables. So in your main function, whatever you define inside round brackets, and it stays just there. That's its life. The lifetime of the variable that you declare is just those round, the curly braces. As soon as you leave the curly braces, the variable stops existing. Okay, that's called scoping. Now in C, you can have variables in different scopes. You can have a globally scoped variable, as in you declare a variable that's accessible through different functions in your program, not just main. You could have 10 different functions and accessing just one value. For that, you have to declare global variables, and then you have local variables. The scope of a local variable is just the function in which it's declared, whereas the scope of a global variable is the entire program from wherever it's visible. Okay? So, moreover, I think we don't have time, else I would have shown you how to declare more functions beside main and do more work with the scope of the variables. But suffice to say for now, I'm just giving you an overview. So note that when you're declaring variables in functions, you can append static to it. Now static is the magic word that makes a variable persist even after its lifetime, even after the end of the bracket or the closing curly bracket. Okay? So imagine you have two functions. One is main, other is foo. Okay, I have my main function, and from main I'm calling foo, and my foo function is defined like this. It's a void, let's say, foo. And in here I have a variable declared int x. So when my program runs, main is the first function that gets called. When the program counter goes to foo, it comes here. And it declares the variable x, executes the function, and as soon as it leaves this curly braces, the closing one, x dies. And then it comes back to the main program, okay? That's the usual flow. But if I were to append or prepend static to int x, if I were to say static int x instead of int x, that means that the value of x will persist even after the function has returned to main. Okay, so that's what static does. So this locally scoped variable x continues to persist even after this function foo returns to main. And what's the advantage of that? Can you think of a scenario? You're Java. You're talking about Java, right? You've done Java. So when you say public static void main, what does static do there? That's okay. So static here, what it does basically here is, for this example, it's good for making a variable persist beyond its scope. Okay. Now, if you want to write a program wherein you want to keep a count of how many times your function got called, you can declare a variable inside this function, and you can do something like x equal to x plus 1. That's the first, second statement in your program. Okay. And let's say int x equal to 0 here. No, let's say int x here. Okay? And when every time a program comes here, x is incremented by 1. Okay? So if my program gets called 10 times, this x will always have the previous value. Let's say this is the nth time where n is equal to 5. When my program comes back here, x is not reinitialized. It's set at 5 already. So now it will be 5 plus 1, 6. That will be the value of x here. That's how it works. So that's about static variables. Besides static, you could have other types of variables like register. Okay. So inside the memory of the computer or the processor, there are different registers wherein it puts the stuff to do the computation, right? How many of you are familiar with digital logic? Logic design? So do you do all those arithmetic logic unit stuff and moving instructions from one place to another? Kernel maps and stuff? Okay. Maybe it's like maybe the next class that you have one that will be on this. No, it's called microprocessor programming.
Oh, I'm taking that. I'm taking microprocessor
next semester. Okay. Move, jump, all that stuff. Yeah, yeah. So all that stuff is done inside the registers. I mean, not all. Most of the stuff is done inside the registers of the processor. It's the fastest place to access your data, the registers. Okay. Just to give you a general overview, you have your main memory, which is RAM. Okay. Then you have your secondary storage, which is like a file system. If you're working on Stampede, it's like work, home, scratch file systems. And then there's tertiary storage, or tertiary memory, which in case of TAP is like Ranch. It's a tape archive. So there are magnetic drives or tapes that are spinning on which your data is stored, and that's the slowest form of storage. The less slowest is the online drives, the hard drives where your data is residing. And then that's a middle tier. And the fastest is the RAM. But something that's faster than RAM is the cache, right? Cache in the registers. So when you try to make a variable memory resident, or you're telling it to reside in the register of the memory, you're trying to tell the compiler not to swap it. Make it available there for the complete execution of the program. And that's a request you make to the compiler. And the compiler is a free bird. It can ignore your request. It can say, well, I don't have time to keep this stuff in the register. I don't have space. It can ignore your request. But you can try.
As in, it's just an optimization strategy for your program that you tell the compiler to place a variable in the register, in the machine registers, okay, for faster access and execution. Okay, now coming back to the constant part, if in your circle program, wherein you can compute the circumference of the circle, if instead of saying double pi or float pi, you want to restrict it, you want to say that never change its value, you can say const in front of it. Put const and then say double and then say the variable name and then the value. So that's how you will declare a constant variable. Okay. So in C, you can define constants in 3 ways. Either you can use the const type specifier like that, or you can have macros, hash defines. So far you have used hash or pound in one more context. What was that? Include. Yeah. And that's a preprocessor directive. Macros are also something for preprocessor to look at. Wherever in your program the preprocessor will find hash define, it will read what's the following word. It says, oh, they're trying to define max records as 100. So wherever in your program you have used max records, it will replace that with 100, the real value. That's what preprocessor does. And why would you use that? So let's say if you have a long program and you want to try running it with different values, you can make a macro like that, like hash define macro, set it to a value, and you can use the macro name, like match records, at 10 different places. Now next time when you run the program, instead of updating like at 10 different places or 100 different places, you just change the value at one place, wherever that is defined. Okay? So that's one way to create constants. And the third way to create constants is creating a list, or enumeration list to be precise. So enumeration is a list of constant values. So in C, what are the data types that I told you we have? Int, float, double, char. Yeah, sort of. You don't have a string type per se, but you can create strings out of character arrays. No. Type is the type specifier. It's not a data type. So, well, did I tell you anything about Boolean? Because there is no Boolean in C. There's no Boolean type defined in C. Yes. So if you need one, you can create one for yourself like this, in a Boolean, and you can say like no or yes kind of thing, or true, false, or whatever. Okay? That's how it works. Okay. So that was about constants and variables. Now let's quickly look at some operators in next 4 minutes. So in C you have arithmetic operators like plus, minus, divide. And there's this guy called modulus, that percent sign. Now you've already seen that at some other place. This percent guy. Where did you see percent sign so far in the programs? Printf statements? Okay. Do not confuse that guy with this one. That percent sign is for specifying the format specifier in your printf statements. This percent sign is an operator. That's what you use when you're doing some arithmetic. You put it there. That percent sign is good for printf statements and scanf statements. Okay. This modulus operator, it gives you the remainder of a division. If you were to divide 10 by 3, what's the remainder? 1. So if you say 10 mod 3, you'll get 1. But if you say 10 divided by 3, what will you get? 3. The quotient. Right? That's what modulus does. Then you have unary operators, plus, plus, and minus, minus. It's called unary because it doesn't need any other operator, any other operand. So, like we saw other examples in the previous slide, like, let me back up here. Okay. Now here, when I'm computing the new value of age, I'm using the older value of age and a number 20, and plus is used in between. So plus operator needed two operands. One of the operand is age, other operand is 20. Okay. With plus plus operator, we can work with just one operand. When you say age plus plus, for example, it increments the value by 1. Plus plus means take the variable and increment its value by 1. Minus minus means take the variable and decrement its value by 1. That's what these two are. And then the equal sign. Then besides these arithmetic operators, we have relational operators. Like if you are doing some comparison between values, like A equal to B, you're testing it for an if-else statement, you would use that. And there are logical operators like and, or, not. Okay. Exclamation sign here in front of A means you're trying to compute the opposite of what A has. If A is 1, not of A is 0. That is, if it's true, flip it to false. No, not. Not. Exclamation is not. For or, you use two pipes like this. Okay? And this is and, two ampersand signs. Okay. Then we have members and pointer variables and the size of operator and so forth. And unfortunately or fortunately, we have just 1 minute. So you are free from learning all of this from me. And there are references that I have on the slides. I'm not sure if these slides are accessible to you. Are we going to give you guys the training material?
I think that's a little comfortable.
Ah, okay. So if you need the copy of this stuff, not Sterling, everybody else, you can ping Rosie, and Rosie, I can pass it on to Rosie.
Like I could send them out as well. Like I could send them to Rosie.
Okay.
Yeah.
Okay. Awesome. Okay. So that was about increment, decrement operators, and here's an example. As I told you, if you have int I equal to 6, and you have int j, and you say j equal to plus I, that means what is the value of j? It's incremented first and then assigned. Yeah, perfect. And what happens if you do I plus plus?
Still 6.
It assigns 6 and then increments, right. Okay. So I'll leave you guys on your own after this point to explore C. And if you have any question, feel free to ping Rosie, or you can contact me directly. My address is there on the TAC website. I mean the email address. So.
Are you teaching us tomorrow too, in the afternoon?
No.
Oh, is it?
Yeah. Thank you for the wonderful class. Thank you. My pleasure. Do you guys have any other instructor coming to talk to you, or are you guys done for the day?
Oh, yeah, they were.
Okay.
Yeah.
Tomorrow's 4 p.m.
Wow.
Yeah, tomorrow is Fortran and FBI. Yeah, I mean, I just took that level Victor, that class, that whole communication class. So we just need to see how much they can condense into like 3 hours or how long is 3.5.
Why are you even tearing that part? I mean, all this part. You already went? You already know more than.
Yeah, I think they required me.
Oh.
Yeah.
Oh, no.
I mean, I think they're like.
Tell it that you already know all this stuff?
Yeah. Yeah, very cool. But I mean, it's fun because, like, you know, some things are being refreshed a little bit. I'm sure I've forgotten a little bit of Fortran by this point. I'm actually going back to relearning, not relearning, diving into C++, but we learned how to class. It's so interesting. There's so many libraries to use. It's pretty crazy stuff. SJ. She's
you guys who do fossil stuff, geosciences, and some mechanical engineering lab is here for sure, but it's not like the process. But this is like micro engineering, like they fetch
Yeah, they had like my teacher.
yeah. I'm not sure if they have to look at it.
Yeah.
There are 86.
Yeah.
So 86 officers.
Yeah, so I'm not quite sure if I'm going to be up here on the big pool, if I'm going to be back at UT campus, but yeah, maybe do some on campus.
That's
Yeah.
nice. Try it.
Oh yeah, for sure. I've never done it. Should be a lot of fun. That walk. I was a longer comment.
Sure. How do you do it? The Ethernet cable or Wi-Fi? Yeah. If it's on a pen drive, it takes you to the printer. Okay, you can go. Then you want to go to gallery, front desk. Yeah, because our the network computer is very Ethernet.
Something like
Wait, Zach, no. Zach, wait.
I'm sorry.
Yeah, don't forget to print out the sockets. Yeah, thanks for
Because I feel like it's a like a lot of now in the same planet with me, apparently doesn't make me shit in high school.
No, not the interview.
No, they just like, my little brother is 15 and he's a better programmer than me. And he builds computers.
Because I want to make sure it's clear. Like I know it's cool because I know the student really well. I can explain to her. I can explain how my because I had a criteria that I didn't understand what the professor said. He literally taught me in the best way, and I was like, oh my god.
I came to UT to do accounting.
Now when it comes to Linux, no.
I came to accounting because I was like, dude,
I didn't see it. I took theatrics.
Oh my god.
Then I took film accounting. I was like, oh my and I hated the it's fun though.
Hope everyone gets on this. That's on that side important. Right there. I saw it the first time. Nico seemed to impress him.
You know what? Then if you want to let you get
Really? Okay, I can't read computers just because I'm really tempted to like get on the computer. And then if I'm in a huge class, I need to sit towards the front because I know that my ass is not.
Go all the way straight and to the right, and that's the right.
Oh, dude, I'm in no rush. The next lesson is not until 4:40. So, Dylan is running. Y'all can be outside.
Shake.
Guys, if you can get like an M&M and I just gave it to someone, you can eat it.
The question a little bit, but
Candy.
if you say it sincerely, yeah, they don't speak the question, but if you say like that accent.
Yeah, okay. It was really funny because this person had an unopened box of history, and I didn't trust her. But then my guy friend trusted her, and she only did it just because her normal box was unopened. So she was like, my ex could like rob a house. She was like, pussy, and then just threw this box of history. You should tell me, dang, if my ex gave me a box of history, I would still take it.
The bus stop comes at 4:30, right?
Yeah, we got a lot of time.
Probably. I mean, that's on the bus.
I don't know if early, but I don't think it was. Actually, when the bus was supposed to arrive at the R1 place at like 8:07 or something, I thought it was late.
I'm just gonna walk over there just in case.
Hello.
Hey. Congratulations,
John.
John. Is everyone's name John?
We have
John.
We have several Johns here.
That guy was John.
We also double up on the Daves.
Oh man.
Not Emily's.
No, not a lot of Emily's. We have a bunch of Matts. We have 2 Valeries. That's close.
I feel like Sarah has a common name in Jasmine.
That's cool. That was really
I
cool.
had a class once, and like this was my school.